Okay, we are going to week number 5, and now we'll be looking at experiment number 5. So we'll click on the link for experiment number 5. And you can see this lab has 2 documents, unlike the previous labs. In the previous labs, we had one document, the procedure, only the procedure. This one has also report sheet. So you need to download the procedure part, follow the instruction in the procedure part, then you'll click on the report sheet part. Okay, don't forget, guys, 2 documents. So let me open the report sheet here. Okay, so this is the report sheet, and you can type into it. Make sure you type your name. So this is the document. Make sure you enable the share first so that you can type into it. So make sure you type your name, okay, guys? This will enable, this document is not protected, so you can type your name, and make sure to use red font in everything, okay, guys? Red font so that I can distinguish your work from the form, okay? So you'll type your name, for example, Walid Shihabi, and then you'll make sure it's in red, okay? So you'll use red font, and you'll type the date and so on. Here under mass, you'll record your weigh in pounds, okay? Whatever your weight is, okay? Let's say, for example, you are 200 pounds, so you'll type 200 pounds here. Okay, and make sure, yeah, you make it red. And then the same thing for running, whether you're walking or running up flight of stairs, it's still 200 pounds. You have the same mass, you still have the same mass, okay? Yeah, regarding to the weight, guys, no one will know your weight except your instructor, okay? And I will not tell, okay? So make sure to record your weight, okay? That's fine. Then for Newton, you have to convert your weight from pound to Newton by dividing by 0.225, okay? So to give you example here, 200 pounds, when you divide it by 0.225, this might give you around 890 Newton. So the number will increase, as you see here. And again, make sure it's red. And this will be the same whether you are running or walking. You have the same weight whether you are running or walking, okay? All in red font, okay? All should be in red font. Okay, now the vertical height of the stairs. Now the stairs, if you imagine the stairs here, okay, so this is the stair, which is composed of steps, okay? This is the stairs. Now, how can you calculate the vertical height of the stairs? This is the vertical height of the stairs. The whole thing here, D, is the vertical height of the stairs. How can you do that? Of course, you need the ruler or measuring tape, and you'll measure the height of one step only. So you'll measure the height of one step, and make sure you measure it in centimeter. So the unit has to be in centimeter. Okay, and then multiply it by the number of steps. Okay, so D here will be the height of one step multiplied by the number of steps, okay, in meters. This should be somewhere between 2 to 3 meters, okay. If you get something like 50 meters, that does not make any sense, okay. If you got something like 0.05 meters, also it does not make sense. Of course, to convert from centimeter to meter, okay, to convert from centimeter to meter, you have to divide by 100, okay, divide by 100. Make sure you convert from centimeter to meter. So after you get the height of one step in centimeter, you have to convert it to meters by dividing by 100. And then you multiply it by the number of steps. Okay, so the height, any staircase, I mean any typical staircase, is between 2 to 3 meters, maybe 2 to 4 meters, okay? So, and make sure to take picture. I ask you to take photo of the staircase. I can estimate its length from your photo. And also take photo of the measuring tool you use to measure the height of one step, whether it's ruler or measuring tape. Maybe you can take a selfie where the staircase is behind you, okay? to show that you did the experiment. So you record the vertical height, then you'll time yourself walking, then running. You don't need a second person with you, okay? You can time yourself using a stopwatch. You can use the stopwatch on your cell phone and time yourself walking, then running. Again, if you have any medical issues that you cannot run, you can just walk slow for the walking part, and then you can walk faster for the running part, okay? Now, if you cannot climb up a flight of stairs at all, you can ask a sibling or a daughter or a son or a spouse to do it for you, and you'll be timing them. This is the data. The data will involve just measuring the height of the stairs and timing yourself. This is where the data ends. This is the data you collect. After that, it's calculations, okay? So for the work, to calculate the work, you have to multiply your force. And remember, when you are running up flight of stairs, you are applying force equal to your weight because you are lifting yourself. So the force done, the force here, represent the weight, okay? This force here represent your weight. And the distance, of course, is the vertical height of the stairs, okay? Distance is the vertical height. So you're multiplying your weight in Newton, the weight has to be in Newton, by the distance in meter. Newton times meter will give you joules, okay? And you'll see actually that the work done will be the same whether you're running or walking, because simply you're doing the same force, which is equal to your weight, times the same distance, which is equal to the vertical height of the staircase. The work done will be the same whether running or walking. Now, this might be confusing to some students why the work is the same. And this is because we confuse work with power. Okay, there is more power while you are walking, while you're running, but the work done is the same. As long as you are maintaining almost the same speed, you'll be doing the same work because your force will be balanced with your weight. So you'll multiply the force, basically row number 2 by row number 3 here to get the work. Now, power is defined as work divided by time, so it's how fast you do the work. So to get the power, you have to divide the work in the previous row here by the time. Okay, so you'll divide row 5 here by 4, and this will give you the power in watts. Power is in joule per second. So the units here is joule. In terms of unit, it's joule per second. And we call this unit watt. Okay. So 1 watt is basically 1 joule per second. 100 watts will be what? If you have 100 watts machine, 100 watts means this machine has the ability to do 100 joule of work, 100 joule of work per second, and so on. 1000 watts means 1000 joules of work per 1 second, and so on. This is the meaning of the wattage, how much work done per second in joules. Now, horsepower is usually the unit used in most machines. They give you their power in horsepower because watts is a small unit. 1 horsepower is equal to how many power? How many watts? 1 horsepower is equal to 746 watts. Okay, that's why in order to convert your power from watts to horsepower, you have to divide by 746. Okay. And you can see the power will be more for running. Why? Because power is inversely proportional to time. So the shorter the time, the bigger the power. Okay. The shorter the time, the bigger the power. Power and time are inversely proportional. You should know now those terms: directly proportional, inversely proportional. So if you double the time, the power will decrease by 1/2, and so on. Okay. Now for horsepower, you expect somewhere maybe between 0.04 to maybe 1.5 horsepower, depending on how fast you run, and your weight has important effect as well. And now the questions at the end, of course, it will ask you about your values. So you can see here work should be the same since we are going the same force and the same distance. Power will be different between running and walking. Okay, because the shorter the time, the more the power. Now one of the question is about can a slower moving student, like if you have two people here, this is person one, okay, and you have person two, this is person two. Now if person two is slower, so person two here is slower than person one, can person two still have more power? Now think about it. The power is equal work over time. Yeah, work over time. And here work is what? Work is representing the force times the distance. The force times distance, that's the work, over time. So time is not the only factor. Time is one factor, but it's not the only factor. Of course, the slower student will have less power. Okay, the longer the time, the less the power. But there's also the weight. F here represents the weight. Okay, so if person 2 has more weight, enough to offset the time difference, he can get more power. Okay, so power depends on this ratio of weight to time. Okay, weight, the force to time. When we talk about two people, assuming the same staircase, so distance here is a constant because the two people are using the same staircase, so D is constant. So the two variables here is the weight and the time. So the one that has bigger ratio of weight to time will have more power. So if person 2 here, for example, has 3 times the weight compared to person 1, if person 2 has 3 times the weight and twice the time, 2t here compared to t, if the time of person 1 is t, let's say person 2 takes him twice as long, so 2t, which one will have more power, person 1 or person 2? Now, since person 2 has 3 times the weight, this means the weight offset the time. Okay, so it's 3 over 2 compared to 1 over 1. 3 over 2 is bigger than 1, right? So the ratio of force to time is what will determine which person will have bigger power. Okay, the force divided by the time here. Okay, the experimental part ends when you get the height of the stairs, the height of one step, and multiply it, of course, by the number of steps, and you get the time of running and time of walking. Then after that, you can go to your office, to your desk, and do the calculations and answer the questions and so on. All right.